Aspirin is a medicine. Vinegar is not. Psych, now it is. Go to your kitchen and steal all your vinegar, 'cause you'll need a lot of those. Head back to your kitchen 'cause you're gonna need a whole lot of baking soda. As you can see, there's a lot of bubbling happening here. The acetic acid in vinegar reacts with baking soda, aka sodium bicarbonate, to give sodium acetate and carbonic acid. The carbonic acid then decomposes to form water and carbon dioxide, which explains the bubbling. We quickly check the pH of the solution to ensure the reaction has gone to completion. To remove the water, we poured it out on 4 dishes for evaporation during the course of a week. However, we kind of ran out of patience, so we decided to pour all the solution back for boiling. You may have noticed that the solution turns brown. This is because vinegar contains contaminants like sugars and stuff. But just don't worry about it, because A, it's edible in the first place, B, you shouldn't be eating anything that's made in the lab, and C, we're gonna get rid of it anyways. This is what we've left after boiling. Then we proceed to the distillation of acetic acid. Firstly, we add the solid leftovers into a 1-liter round bottom flask. Then we add a tiny amount of concentrated sulphuric acid, just to see how vigorous the reaction will be. After the addition, some white fumes of acetic acid are produced rapidly. The vapor of the acetic acid has to be collected, so we put together a distillation setup.
Boink, 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 boink.
We then added the rest of the acid into the flask. Immediately, the white fumes rushes out. Not adding ice cubes prior to the addition of the acid was definitely a dumb move. The sulphuric acid, being the stronger acid, displaces the acetate ion in the sodium acetate to form acetic acid and sodium sulfate. And this is a really long process, so after the distillation, I discovered some very beautiful sodium sulfate crystals left in the bottom of the beaker. We washed the crystals with methanol to get rid of all the impurities. I swear to God, these crystals only grow when I don't ask for it. Anyway, we obtained around 40 milliliters of concentrated acetic acid. So now we can proceed to the next step. I weighed out 8.1 grams of salicylic acid, which can be found in some shampoo and hand cream. Then we added the salicylic acid into a small beaker followed by 20 milliliters of the distilled acetic acid. And when the solution becomes clear, a few drops of concentrated sulfuric acid were added as a catalyst. We turned on the heating to prepare a warm water bath and kept the solution at around 70 degrees Celsius. During the reaction, a water molecule is eliminated so that the salicylic acid and the acetic acid are esterified to form a 2-acetoxy-benzoic acid, aka aspirin, the product of our synthesis. After 10 minutes of the heating, the beaker was taken out and placed in the cold water bath to foster crystallization. And this is the product we're looking for. Unlike the sodium sulfate crystals we've made earlier, the aspirin crystals are smaller and more delicate. Solution remains cold. A quick filtration was performed to collect the aspirin crystals. We could have ended the video here, but honestly, this right here wouldn't make a good outro, would it? We scraped the residue to a smaller beaker and added an excess amount of ethanol to redissolve it. After that, it was placed back to an ice bath for recrystallization. This time we allowed a slower crystallization, and the crystal form is like a delicate fiberglass. It set for a few hours and was filtered out and put on a piece of paper to air dry. Well, if you look closely to the crystal, you'll find that it looks like well, it looks like um uh,